Hi Year 10. So today we are going to start a new topic, which is developments in new materials. This topic will cover four broad categories of new materials that have not been around for that long, and we're going to learn about what they are, their different properties, and their potential and current uses within design and manufacture. So can you turn to this page in your theory booklets where it says modern materials at the top and write down the learning objective, which is I will learn about smart materials to see how new developments could be used in design. Pause the video here and write down the learning objective. Amazing. So what are modern materials? Modern materials are new materials that have been developed to have properties that are useful when designing and making products. So the materials that have been engineered to have better properties, improved properties. Our first modern material we're going to look at is graphene. And what graphene is a single carbon layer material that is roughly 100 times stronger than steel. So when we're going through these, I want you to add notes to your page. So graphene is made up of a single layer of carbon, and it is extremely, extremely strong. I can't emphasize how strong this material is. But unfortunately, it's a bit of a pie in the sky material because we're not able to manufacture it in large enough quantities to use in larger scale items or products, and it's very expensive to manufacture. It's only something that we can manufacture within a lab in very controlled small scales. So we cannot prove 100% that this is as extremely strong when it's in a larger material piece, but if it keeps its strength when it's this smaller material, then if we can get to a point where we can manufacture it at a huge scale, then it will become one of the most useful materials on Earth. So it's got several properties. The first one, that it's very flexible. Even though it's strong, you can flex it and it's got a lot of give to it. You can mold it and it has a lot of impact resistance, so it's very flexible. It also conducts electricity and heat, which is a very useful property in terms of thinking about using it for different products. It's transparent, so you can see through it partially. It is also very, very lightweight. It's actually the lightest known material that we have on Earth, or that we've found. It's the lightest material. And as I've said before, it's insanely strong. So here I put potential uses because obviously we cannot manufacture it to a large scale, therefore it's not being used in products or manufacture at the moment. But let's think about if we get to a point a few years down the line where we are able to manufacture it in high quantities and cost effectively, the uses are pretty much endless. So, for example, if Wembley Stadium, one of the biggest stadiums in the country, was fully made out of graphene, it would technically be indestructible. It would be so strong that nothing could break it. But it would also mean that because it's very lightweight, you'd also be able to, one person would be able to lift it up, the whole of Wembley Stadium, with one hand, with one finger. So that kind of puts it in perspective how strong and how lightweight this material is. And if we ever get to a point where we can produce it in large quantities, it will become the most useful product in the world. And potentially it could be used as body armor that is bulletproof, invisible, and pretty much like weightless. So pause the video here, make sure you've got all that information before playing the video again and moving forward. Okay, so our next material is one that you've probably heard of before. It's titanium. And titanium is a modern metal that is the fourth most abundant in the world. So abundant means that it's there's a lot of it available on our Earth. The properties for titanium is the main one I want you to stick in your head, that it's got a very high strength to weight ratio. As we go through this course, this phrase, strength to weight ratio, will come up a lot with different types of materials. And titanium is one of the materials that has a very high strength to weight ratio. So that means that for a small weight, it's got a very large strength. So it's very strong even in small quantities. And that kind of compounds up into when you're using larger pieces of titanium, it is very, very strong. But it is quite heavy because it is a very dense metal. It's also resistant to corrosion. So it's got a good chemical resistance, so it does not break down in harsh climates. It doesn't weather very easily, so it has a higher durability than some other metals that you know of. And there's many, many uses for titanium, but we're only going to go through a few. First one is sports equipment. So titanium is often used for golf clubs because it's very, very strong, and it does not weather, or it doesn't corrode easily, so it's very easy to clean, and it doesn't degrade, and it's very durable, so it's long lasting as when it's used in sports equipment. But also it's used for medical applications, so in lots of surgery where you have to have stents put into your legs, or when you have hip replacements, or when you might have to have a plate put into your shoulder because your shoulder blade is wearing down, they often use titanium because the chemicals in our body will not break it down and release harsh chemicals into our body because it's got that resistance to corrosion. But it's also very long wearing and very durable, so it will not reduce its usefulness when it's in our body, even if it's a decade after it's been implanted. So pause the video here, make sure we've got that information before moving forward. Okay, the next one is probably one that everybody has heard of, LCD. We all heard of LCD TVs, flat screen TVs. This is the material that made flat screen TVs possible, which made mobile phones possible, which made any digital device that is relatively thin and has a screen will at one point have used LCD technology, LCD material. And LCD stands for a liquid crystal display. What it is a laminated material. So a laminated material is a material that has several very thin layers of a material put together. So LCDs has multiple layers of glass, where in between those two layers has a liquid crystal core. So it's got liquid crystals, and those liquid crystals have light modulating properties. What that means is when an electrical current passes through it, it will display different colors. And that's how we get images coming up on our TVs, because the different electrical impulses through the LCD screen will determine what image you can see on the TV. And there's a very, very, very short delay, so there's no lag in image and audio. The properties: it lets light through when voltage is applied. So when electricity passes through it, and at what frequency or what strength, it will let light shine through the liquid crystals. And it's very specific as to what voltage will allow what coloured light come through. but it also blocks light when there's no voltage. So when there's no electricity passing through it, light cannot pass through the liquid crystal display. So when it comes to uses, you know the uses already, I'm assuming. First one, digital watches is a good example. So your Fitbits, your Apple Watches, they use a liquid crystal display on a very small scale. But also flat screen TVs. Most flat screen TVs, when LCD material became readily available and easy to manufacture, all the TVs turned from these huge, square, big monstrosities into these nice flat screen TVs that we have today. So pause the video here, get all that information down, and then we'll move on. Lovely. So our final material is metal foam. So you may not have heard about this before, but metal foam is basically made by pumping gas or a foaming agent into molten metal. So once we have melted metal into its liquid form, we can either inject gas into it at very high pressure to expand within the metal, so that when it sets, we are left with all of those little air pockets and bubbles inside. And what that does is it creates a high compressive strength. So what I mean by compressive strength is it can resist compression to a high degree. So compression is a force that acts down onto a material or onto a product. So use your hand, press it down onto your desk or whatever you have your laptop or device on at the moment, push down, and you can probably feel that there is, like, the table have some give, it will start bending. That means that the product you're pushing down on now does not have a very high compressive strength. If whatever you're pressing down on now was completely made from metal foam, there would be no give. You would not feel your hand moving, it would just hit, it would be almost like pressing your hand down onto the floor, because it can resist that compressive force. That makes it a very useful material in certain products. It also absorbs energy well. So it's impact resistant because it's got those air bubbles. It opens up the structure and it creates lots and lots of strength, so it can absorb energy well. But also it's very lightweight. So when we pump air into it, it's got all these air bubbles, which reduces the density of the material, which means that overall it becomes a very lightweight material, but it has that high compressive strength. So the benefit to metal foam is that it is lightweight and can be used in multiple things, but it does not reduce the strength and the compressive strength of the original metal. So it keeps most of its strength, but with much less weight because of that air being pumped into it. And then when it comes to uses, it's often used in soundproofing on large scales, for crash protection in vehicles, and filtration. So metal foam can be used to filtrate different, to filter different gases and different liquids through within different products. So pause the video here, make sure you've got all that information. Lovely. Now what I'd like you to do is close your booklet, and we're going to go through some practicing our knowledge, some knowledge retrieval of what we've just learned. So make sure your booklet is closed. Be honest with yourself. This is the no stakes quizzing. So we've got on the left hand side are 4 modern materials: metal foam, graphene, titanium, and LCD liquid crystal displays. On the right we have definitions or descriptions of what they are. So we've got a single carbon layer that is roughly 100 times stronger than steel. Something that is made by injecting gas or a foaming agent into molten metal. A laminated material of 2 layers of glass with a liquid crystal core. And a modern material that is for the 4th most abundant. What I'd like you to do, I'll give you 30 seconds, try and match the definition on the right to which material it's talking about on the left. So pause the video here, try to match them together, then we'll go through. Okay, so metal foam, which one is it? Is it the top one here, the second, third, or fourth? If you said the second one, you are correct. Metal foam is made by injecting gas or a foaming agent into molten metal. So, next one is graphene. Is it the top one? Is it 3? Or is it 4? If you said 4, you've got it right. It's a single carbon layer of material that is roughly 100 times stronger than steel. The next one, titanium. We've got 2 options left. A laminated material of 2 layers of glass, or a modern material, modern metal that is 4th most abundant. If you went for this one, you are correct, which means that LCD is a laminated material of 2 layers of glass with a liquid crystal core. Ramping up the difficulty here a little bit, so we've got a set of properties that links to one of our modern materials on the left. So the properties are: lets light through when voltage is applied, and blocks light when voltage is switched off. Is it metal foam, graphene, titanium, or LCDs? Shout your answer at the screen now. Okay, if you said LCD, you are correct. Let's move on. The next set of properties keeps most of its strength, but with much less weight. It has a high compressive strength, it absorbs energy well, and is very lightweight. Is it metal foam, graphene, titanium, or LCD? Shout your answer to the screen. If you're saying metal foam, you are correct. The next set of properties, resistant to corrosion and high strength to weight ratio. Which one is it? If you said titanium, you are correct. And finally, a very strong material that is also very lightweight, transparent, very flexible, and can conduct electricity and heat. Which material am I talking about? If you're saying graphene, you are correct. That is the end of today's lesson. Make sure you've got all of the notes down in your in your booklet, and I look forward to seeing you next time. Thank you guys, and goodbye.